Good morning, everyone. So today let us see the remaining types of matrices. So before that, let us revise what all we have studied about relations. So what do we mean by relations, students? Relation is nothing but subset of the Cartesian product A cross B. So relation it is nothing but subset of the Cartesian product A cross B. This we say that this R is a relation from set A to set B. Suppose we are talking about the single set A. Then if the relation is subset of the Cartesian product A cross A, then we call that relation is the defined on the set A. Relation is defined on the set A. Right? First type of relation which we learned, students, that was null relation, right? What is null relation? The relation in which no element of the set A is related to any other element of the set A is nothing but null relation. Mathematically, how we can write it? A is not related to A for every A belonging to set A. Suppose the relation R is defined on the set A, then if any element of the set A is related to any other element of the set A, then such a relation is called as null relation or void relation, or you can say it as empty relation. Right? Now, next type of relation was universal relation. What is universal relation, students? It is nothing but in that relation, every element of the set is related to itself as well as to one another. So mathematically, you can write A is related to A as well as A is related to B for every A comma B belonging to set A. Means what it says, students? Every element of the set is related to itself. A is related to A as well as every element of the set is related to every other element of the set. Then you say such a relation is nothing but universal relation. This null relation will be nothing but empty set, right? That empty set is subset of any set. It is subset of the Cartesian product A cross A also. So this set is said to be empty relation. What is universal relation? Here R is nothing but entire set A cross A. And as every set is subset of itself, A cross A will be subset of A cross A itself. Right? So this is a relation, and which type of relation is this? This is nothing but universal relation. Lastly, what we learned? We learned about reflexive relation. In reflexive relation, what is our students? If we define a relation R on a non-empty set A, then if every element of the set A is related to itself, then you say that such a relation is called as reflexive relation. Mathematically, it is written as A is related to A for every A belonging to A. That means every element of the set A is related to itself. Then such a relation is called as reflexive relation. Now let us see few more examples of this reflexive relation. Suppose we have given the set A containing three elements 1, 2, 3. Okay. Now I will give you one relation. Say R is equals to 1, 1, 2, 2, 1, 2, 3, 3. Just tell me, students, whether this relation I have defined here is reflexive or not. Please just observe and answer me whether this relation which I have written here is reflexive relation or not. Is this relation reflexive? You have to observe whether each element of the set A is related to itself or not. Yes, students, please answer. whether this relation which I have defined here is reflexive relation or not. Yes, it is reflexive. So someone says that it is reflexive, right? Of course it is reflexive, students. Why? Because here, how many elements in the set we have? We have 3 elements in the set, right? Then those are 1, 2, and 3. Now let us see whether these elements are related to itself or not in this relation. First element is 1. Here you can observe that in this relation R, 1, 1 belongs to R. This ordered pair is belonging to R, right? This is that ordered pair. What does that mean? This means that 1 is related to 1. First element 1 is related to 1. So it is related to itself. Now let us take a second element. If you take a second element, is 2, 2 belonging to R? Yes, of course 2, 2 is also belonging to R. So what does that mean? It means 2 is related to 2. That is, 2 is related to itself. Right? Now let us take the third element. What is the third element? 3, 3 belonging to R. So this ordered pair 3, 3 also belongs to R. Right? So what does that mean? 3 is related to itself. So what we can see? We can see that these 3 elements are related to itself. 1 is related to itself, 2 is related to itself, 3 is related to itself. So these 3 ordered pairs you have in a relation. You might be wondering, what is this one more extra element doing here? That is 1, 2. Don't worry about this extra element, students. 1, 2 does not matter at all. Even if it is there or if it's not there. It does not have any role in this relation. Right? You just, in reflexive relation, you just need to observe that every element of the set is related to itself or not. You just have to conclude with that. If every element is related to itself, then that is enough. You can see that these 3 elements belong to the relation R. So what you can conclude? You can conclude that the relation R is reflexive. Don't worry about the extra element which you are seeing here, 1, 2. It doesn't play any role in our relation. Reflexive relation definition is only this much. Every element of the set should be related to itself. If that is true, then you conclude that the relation is reflexive. So here what you can observe that this relation is reflexive. Now you can give one more relation. R is equals to 1, 2, 2, 2, 3, 1, 3, 2. Now tell me, students, whether this relation is reflexive or not? Just answer whether this relation is reflexive or not. Yes? Just check it. Check all the order pairs. For reflexive, what you need to check? You need to check only one thing. Every element of the set should be related to itself. Now tell me whether every element of the set is related to itself in this relation. Yes, students? Afreen is saying that yes. I want still more answers. I want everyone to think over it. Then only the basic things will be clear for you all. Yes, anyone else? Okay, Bhavesh is also saying yes. So, you people are saying that this is a reflexive relation. Definition, what it says, students? Every element of the set should be related to itself. Now let us go from the basic definition. But let us take the first element, that is 1. Now is 1 related to 1? Is 1 related to 1 here? Just check. Is 1 related to 1? Means, do we have an ordered pair 1, 1 belonging to 1? No, right? Then how you can tell that this reflexive, students? What I told you, definition itself says that every element of the set should be related to itself, right? So, but if you take the first element itself, that is 1, 1 is not related to 1 is not related to itself. Because we don't have ordered pair 1, 1 in a relation. You can observe we don't have that ordered pair in a relation. If you take the second element 2, 2 is related to itself. If you take the third element 3, 3 is related to itself. Don't worry about these other two pairs. They don't play any role in this relation. But we don't have first element or first ordered pair. First element is not related to itself. If at least one element is not related to itself, then you conclude that the relation is not a reflexive relation. Each and every element of the set should be related to itself. Then only you conclude that the relation is reflexive. So here what we saw that one is not related to itself, and hence you conclude that the relation is non-reflexive. Is it clear? Bhavish, Afri? So did you understand how it is not reflexive? Why it is not reflexive? Is it clear, students? Okay. Now let us see the next type of relation. Please remember these things. Reflexive means every element of the set should be related to itself. If you have any other ordered pairs in the relation, don't worry about that. But only one thing you should confirm. What you need to confirm? Every element of the set should be related to itself. If that holds true, then you conclude that the relation is reflexive. And let us go for the next type of relation, that is symmetric relation. Symmetric relation. Let us again understand this relation with the help of an example. Now suppose we have set A is equals to girl, comma, boy. We have the set A is equals to girl, comma, boy. Suppose I will define a relation R as both are of different gender. Suppose I am defining this relation R as both are of different gender. Both are of different gender. Okay. Now first of all, what we need to find? To find this relation R, first of all we must know Cartesian product A cross A, right? Here you can observe that A has two elements. Therefore, A cross A will have how many elements? Can you tell me? If A has two elements, A cross A will have how many elements? Yes? 4. Very good. We have A cross A will have 4 elements. 2 into 2 is equals to 4. Now, if I take this girl as G and boy as B, what will be my elements? Girl, comma, comma, boy, boy, comma, girl, boy, comma, boy. So these are the 4 elements. Right? These are the 4 elements of the Cartesian product A cross A. Now we need to find the relation R. How it is defined? It is defined as both are of different gender. So let us see what does this relation R will include. So to find the relation R, what you need to concentrate on? You need to concentrate on the elements of A cross A as well as how the relation is defined. How the relation is defined? Both are of different gender. Now if you take the first element, girl, comma, girl. Will you include this in our relation, students? Girl, comma, girl. No, we can't include this, right? Because both are not of same gender. So this is discarded. If you take the second element, girl, comma, boy, yes, we can include this because they both are of different gender. Similarly, boy, comma, girl, we can include. Last boy, comma, boy is not included because they are of same gender. So the relation, it seems like this. So here what you can observe, students, in this relation, what you can observe, if you have an element, if you have an order pair A comma B belonging to R, then you will be having A B comma A belonging to R. Suppose if you see that 1 comma boy is belonging to R, then in return, if you are able to say that 1 comma girl is belonging to R, then you conclude that such a relation R is symmetric relation. In general, I need to tell like this. If we have an ordered pair A comma B belonging to R, then in return, if you are able to say that we have another ordered pair B comma A belonging to R, then you conclude that such a relation is called as symmetric relation. That is, if A is related to B, if you have an ordered pair A comma B belonging to R, that is A is related to B, then if in return you are able to say that B is related to A, that is ordered pair B comma A also belongs to R, then you conclude that the relation R is symmetric relation. So, definition how we can write? Definition is a relation R on a non-empty set A is said to be symmetric relation if for ordered pair A comma B belongs to R. If ordered pair A comma B belongs to R, then in return you must be able to say that ordered pair B comma A belongs to R for every A comma B belonging to set A. Once again I repeat. A relation R defined on the non-empty set A is called as symmetric relation if A comma B belongs to R, then in return you need to say B comma A belongs to R for all A comma B belonging to R. This definition will be more clear if you see few examples. Suppose I give a set A is equals to 1, 2, 3. Okay, so this set contains 3 elements 1, 2 and 3. Suppose I define a relation R is equals to 1, 2, 2, 1. So this is my relation R. So as I told in the definition students, if you have an ordered pair A, B belonging to R, then you must be able to say that B, A also belongs to R. If you are able to say that, then you conclude that the relation is symmetric. Now tell me by looking at this relation whether it is symmetric or not. Just try. Is this relation symmetric? Kusma. Yes, it is symmetric. Very good. It is symmetric. Why? Because if you consider the first ordered pair here, 1, 2. 1, 2 belongs to R. That is 1 is related to 2. So for this relation to be symmetric, 2 must be related to 1, right? 2 must be related to 1. If 1 is related to 2, for this relation to be symmetric, 2 must be related to 1. Of course, 2 is related to 1 because we have another ordered pair 2, 1 belonging to R, right? For A, B belonging to R, we have another ordered pair B, A belonging to R. Then you conclude that this relation is symmetric. Yes? Suppose I give you the relation as now tell me whether this relation is symmetric or not. Yes, students? Tell me whether this relation is symmetric or not. It contains 3 elements 1, 2, 2, 1, 3, 1, 2. Just check whether this relation is symmetric or not. Yes? If you take any ordered pair B, belonging to R, in return you must be able to say that B, is also belonging to R. If you are able to do that, then you conclude that the relation is symmetric. Now here, is this relation symmetric? No, it is not symmetric. Zainabi, why it is not symmetric? Let us check. If I consider this element to be A, B, so 1 is related to 2. Right? So if I consider this element A, B belonging to R, so in return what I need to tell? I need to tell that B, A is also belonging to R, right? So in return, am I able to say that B, A belongs to R? Yes, of course. 2 is related to 1. We have that ordered pair also. So for A, B belonging to R, we have another ordered pair B, A belonging to R. But this should hold true to any other element in the relation. If you consider this as A comma B, then this will be my B comma A ordered pair. If I consider this as A comma B, then this will be my B comma A ordered pair. But for this ordered pair A comma B, one is related to 3, but 3 is not related to 1. Right? For ordered pair 1 comma 3 belonging to R, you don't have any other ordered pair 3 comma 1 belonging to R. Right? So what do you conclude? You conclude that this relation R is not symmetric. The symmetric definition, students, for every ordered pair A comma B belonging to R, you must be able to tell that B comma A belongs to R. That definition should hold for every element in the relation. Here you can observe, if you consider this as A comma B, you will be able to tell that this is my B comma A ordered pair. If I consider this as A comma B, then this will be my B comma A. But if you consider this ordered pair 1 comma 3, you don't have another ordered pair 3 comma 1 belonging to R. So what do you conclude? You conclude that the relation R is not symmetric. Is that clear? Is that clear, students? I hope, Zainabi, you understood why it is not symmetric. So definition of symmetric is very clear. If you have an ordered pair A comma B belonging to R, in return you must be able to tell that B comma A also belongs to R. If you are able to say that for every ordered pair in the relation R, then you conclude that such a relation R is symmetric. Suppose now I take the set 1 comma 2 comma 3. Okay. Now suppose I will define the relation R is equals to 1 comma 3. Now tell me whether this relation R is symmetric or not. R is equals to 1 comma 3. Tell me whether this relation is symmetric or not. Yes? Is this relation R symmetric? I want answer from everyone. I hope everyone is understanding this. If you have doubts, then please ask me. No, right? It is not symmetric. Why? If you consider this ordered pair to be A comma B, you don't have another ordered pair B comma A belonging to R, because 1 is related to 3, but 3 is not related to 1. 1 is related to 3, but 3 is not related to 1, and hence the relation R is not symmetric. So I hope now the definition of reflexive as well as symmetric is clear. What is meant by reflexive relation? Reflexive relation is nothing but every element of the set should be related to itself. Only that is the definition. And what about symmetricity? Symmetric means for every ordered pair A comma B belonging to A, you must be able to say that B comma A also belongs to R. If that holds true, then you conclude that the relation R is symmetric. Let us see the next type of relation, and that is nothing but transitive relation. Transitive relation. So let us try to understand this transitive relation through an example. Suppose I have a set A is equals to contains again the elements 1, comma 2, comma 3, and the relation R is defined as 1, comma 2, 2, comma 3, 1, comma 3. So here, please observe, students. If you have ordered pair, if I have ordered pair A comma B belonging to R and B comma C belonging to R, then in return, if you are able to say that A comma C belongs to R, then such a relation R is called as transitive relation. Once again I repeat, if we have two ordered pairs, I repeat, if we have two ordered pairs A comma B belonging to R and B comma C, here second element of the first ordered pair and the first element of the second ordered pair should be same. So if you have two ordered pairs A comma B belonging to R and B comma C belonging to R, then in return if you are able to conclude that the third ordered pair A comma C is belonging to R, then such a relation is called as transitive relation. Then such a relation is called as transitive relation. Now check here. By definition, tell me students, is this relation are transitive? Here you can observe 1, 2 belongs to R. 1 is related to 2. 2, 3 is related to R. 1 is related to 2 and 2 is related to 3. Right? So we have two ordered pairs A, B and B, C. Right? We have two ordered pairs A, B and B, C. So in return, what you need to tell? If you are able to say that A, C. What is A, C? 1, 3. If you are able to say this, if A1, 3 is belonging to 1, then you conclude that the relation is transitive. Yes, of course it is transitive, right? Because this is A, B and B, C. Then we have the third order pair A, C also belonging to 1. So you conclude that the relation R is transitive relation. Shall I explain it once again, students? Transitive relation. Transitive relation is it clear? We will see few more examples on that. Is the definition clear? Okay. So I repeat once again. If you have two ordered pairs, A, B belonging to R and B, C belonging to R, then if in return if you are able to say that ordered pair A, C is belonging to R, then you conclude that the relation R is transitive relations. Now tell me. Suppose I give the relation R as 1, 2, 2, 3, 2, 2. Now tell me whether this relation R is transitive or not. Yes, students? So answer whether this relation R is transitive. No, it is not transitive. Why? Because you have ordered pairs A, B as well as B, C. But you don't have another ordered pair A, C belonging to R. So what do you conclude? You conclude that the relation R is not transitive. Here you can see 1 is related to 2 and 2 is related to 3. But 1 is not related to 3. So what do you conclude? You conclude that the relation R is not transitive. Let me give you one more example. Answer me, students, whether this relation R is transitive or not. Tell me whether this relation R is transitive or not. Uzma. So she is saying that it is transitive. Any other answers? We have 17 participants, right? We have 17 students. So at least I want 15 answers. Okay. Anyone else? Yes. Okay. So you are saying that this relation is transitive. So let us check whether it is how it is transitive. So here first order pair and second order pair. They are of the form A, B and B, C. Right? So 1, 2 belongs to R and 2, 3 belongs to R. So these are of the form A, B and B, C. Right? So in return, we are able to say that one A, C. What is A, C? That is 1, 3 is belonging to R. Of course, this is true, right? Yes, it is true. But if I consider these two ordered pairs, now here, please observe, students. If I consider these two ordered pairs, 2, 3 and 3, 1. So these are also the form A, B and B, C, right? See, observe here, 2, 3 and 3, 1. 2, 3 belongs to R and 3, 1 belongs to R. These are also the form A, B and B, C. So in return, what I need to tell? I need to tell that A comma C. What is A comma C? Is 2 comma 1. Is this ordered pair belonging to R? Yes, tell me. Is this ordered pair belonging to R? 2 comma 1. Yes, students. Answer whether this 2 comma 1 ordered pair is belonging to R. No, right? So for another pair of ordered pairs, 2 comma 3 and 3 comma 1. We don't have ordered pair 2 comma 1 belonging to R. This does not belong to R. So the definition of transitive goes off, right? What does the definition say? If you have two ordered pairs A comma B and B comma C belonging to R, then in return you must be able to tell that A comma C belongs to R. But here, for this first two ordered pairs, it holds true. But if you consider these two ordered pairs are also of the form A comma B and B comma C, right? So of course, A comma C should belong to R for the relation to be transitive. But here, A comma C does not belong to R. So what do you conclude? You conclude that the relation R is not transitive relation. Did you all understand, students? This relation is not transitive because the definition should hold for every two ordered pairs, whichever out of the form A comma B and B comma C. Is that clear? Is that clear? In exams, they will confuse you with this. So you must be very careful to check the definition for each and every ordered pair, students, in the relation R. I hope this is clear. For these two ordered pairs, the definition holds true. But if you consider these two ordered pairs, they are in a relation. They are of course in the relation, right? But for those two ordered pairs, you don't have ordered pair A comma C belonging to R. So what do you conclude? You conclude that the relation R is not transitive. Suppose I give you one more example. Yes, now answer whether this relation R is transitive or not. Please answer, students. We are running out of time, only 5 minutes left. I want to complete this transitive relation. Just answer whether this relation R is transitive or not. Please be very careful now. I already repeated the definition thrice. For any two ordered pairs A comma B and B comma C belonging to R, if you are able to say that ordered pair A comma C is belonging to R, then you conclude that the relation R is transitive. Now tell me whether this relation R is transitive or not. Yes? I want the right answer now. Is the relation R transitive? For every possibility, the definition should hold true. No. Okay, let us check. Now, if I consider ordered pair 1, 2 belonging to R and ordered pair 2, 3 belonging to R. So these are of the form A, B and B, C, right? So in return, am I able to say that 1, 3 is belonging to R? Yes, of course I am able to say that. Right? So the relation R is for this ordered pair, it holds the definition holds true. Now let us take the another ordered pairs. Let me say that the relation R is not transitive. So can you give me those ordered pairs, two ordered pairs for which the definition is not holding true? Please just give me those two ordered pairs for which the definition is not holding true. Now if I consider ordered pairs 1, 1 and 1, 2. 1, 1 belongs to R and 1, 3 belongs to 2 belongs to 2. See here, students. 1, 1 belongs to R and 1, 2 belongs to R. So they are of the form A, B